So today we're going to learn about logs and log functions. And once you understand how to convert between exponential and log form, it really is something that you're going to find easy to do. But you have to first really understand how to convert between the two forms. So the definition of a log with base b. You're going to let b and x be both positive numbers, and b is not equal to 1. So the log of x with base b is noted as log base b of x. And it's defined as the exponent y that will make this equation b to the y power equals x true. So I color-coded this a little bit for everyone. If b to the y power is x, then log base b, notice it's the base here, and you have your log base b of x is equal to y. So you can sort of think of it this way. B to the y power is equal to x. So we're going to take these 4 problems here that are written as logs, and we're going to write them in exponential form. So we're going to say 10, because that's our base, to the second power is equal to 100. And hopefully you all recognize that's true. 10 to the second power is equal to 100. Later on, we're going to have some variables there, and we can actually solve for x or y. Right now, we're just writing them from log form to exponential form. So what would 2 be? 2 is going to be 3 to the y power equals 4. So 3 to the y power is equal to 4. And now number 3. 3 is a fraction and a negative in it, but we still know the drill. Our base is 3, so it's going to be 3 to the negative third power is equal to 1 over 27. And that's true, because if we do have a negative exponent, that's like writing 1 over 3 to the third. Go ahead and try 4 on your own. What's your base? Good. So x to the second. And what is it going to equal? It equals 5. Excellent. So now we learned how to write logs in exponential form. We're going to do that in reverse. So we have 7 to the negative second power equals 1 over 49. So again, our base is 7 here. So we're going to say log base 7 of what? Log base 7 of 1 over 49. And what's it equal to? It's equal to negative 2. Let me just change colors. Let's just check what we did before. Is it true? Did we write it right? 7 to the negative second equals 1 over 49. So we did that correctly. Excellent. Next, 4 is our base. So we'll say, hey, log base 4 of 16. And sorry, that is a 4, not a 9 there. And what's it going to equal? It's going to equal x. For 3, what is our base? Our base is b. So log base b of 1/4 is equal to negative 2. And this last one here, our base is what, everyone? Good, 64. So log of 64 for our base. And then we have 16, and it's going to equal 2/3. So now we're going to learn how to evaluate. So basically, we're going to be finding out that missing piece. We don't have equal signs here. So remember, if we have a b to the y power equals x, it's log base b of x equals y. So if I had log base 16 of 4, that would be a half, because 16 to the half power is 4. Remember, that half power is like saying, hey, what's the square root of 16? Which we all know and love to be 4. So let's try number 1 out. Log 2 of 8. So we're going to think to ourselves, actually, let me just show you a trick that sometimes people find a little easier. Let's just say, hey, this is equal to W. So if I do that, I'm going to say 2 to what power is equal to 8, right? 2 to what power W equals 8. So I can rewrite 8 as 2 to the 3rd. So what is W going to be? Well, W is going to be 3. So the answer is, if you see log base 2 of 8, and it's asking you to evaluate, you know that the answer here would be 3. Let's try again with number 2. So I'm going to say this is equal to W again. So let's think. 4 to what power is equal to 1 over 16? Now 1 over 16, I can rewrite that as a 2 to a power, but since we have a 4 here, let me just write it as 4 to the negative 2nd. So what would W be in this case? W is equal to 2. Actually, no, W is equal to negative 2. So log base 4 of 1/16 is negative 2. Pause the video and try to do 3 and 4 the best you can, and then let's check in and see how you do. All right, so I use that little W trick again, and you can use any variable there. So I said for number 3, 27 to what power is 81? Now, since I had 27 and 81, I wrote those as base 3s. So 3 to the 3W, because 3 to the 3rd is 27, equals 3 to the 4th, which is 81. And when I solve that, I get 4/3. So the answer to 3 would be 4/3. And keep that as that improper fraction there. And then for number 4, I have 4 to the W power is 1 over 32. Again, I changed it so it's base 2. So 4 is the same as 2 squared. So I have 2 to the 2W equals 2 to the negative 5th. Again, 1 over 32, we have negative exponents. And we get negative 5 over 2 when we evaluate that. So really make sure you understand how to convert between exponential and log form. The more you practice that, the easier it's going to be when we're graphing logs and when we're working with other things down the road. So now we're looking at the graphs of log functions. Our parent function is f of x equal log base b of x. These are continuous graphs. They're one-to-one. Your domain is from 0, not including 0, to positive infinity, and then negative infinity to positive infinity for our range. Your vertical asymptote is going to be your y-axis. Okay, so that means that your graph's going to approach that y-axis, but it is never going to actually intersect that y-axis. And your intercept, you only have an x-intercept here, and it's the point 1, 0. So let's go through why we have that as our intercept. So again, the x-intercept is where y is 0. So if you want to think about it, and let's think of base 2 here. So log base 2 of x. So we're going to think 2 to the 0 power is equal to, well, what is it equal to? Well, any non-zero number to the 0 power is 1. So that's where we get our point for our y-intercept of 1, 0. So it doesn't matter what the base is. The base could be 15. 15 to the 0 power is 1. The parent graph is always going to have that as your x-intercept. Now, when we're graphing, you're always going to look at your base. So this base is 3. So for problem 1, I know, hey, my base is 3. And I know that 3 to the 0 power is 1. So my intercept is 1, 0. Now our other points, and I have them up at the top in red, are the points, whatever your base is, and then the answer is 1. Why does that work? Let's look. Well, 3 to what power? 3 to the first power is equal to 3. So that's where we get our 3, 1. The other point we're going to have is 1 over our base, which is 3 in this case, and negative 1. And why does that work? Let me change the color up again. So base 3, so 3 to the negative first power. And what is 3 to the negative first? Why, it's 1/3. And that's our x value. So I'm going to do my best to plot those points. So 1, 0, 3, 1, and then 1/3 and negative 1. So 1/3 and negative 1. And I drew my curve the best I could, and I have, this is my graph for y equals log base 3 of x. So for problem 2, our base is 1/2, so I'm going to write that here. And then I'm going to ask you to pause that and try to use this part at the top to figure out what your 3 points would be when you're graphing. So again, pause it and try that piece on your own. Let's see how you do on it. So again, we said our base was b of 1/2 there. So I have written in red those 3 points at the top, 1, 0, b, 1, and then 1 over b, negative 1. So I get 1, 0, obviously that's a tough one, and then 1/2, 1, and then 1 over 1/2, negative 1, which is really 2, negative 1. So plot those points and let's draw that curve. All right, so hopefully your graph of log 1/2 of x looks similar to mine. Maybe your curve looks a little bit fancier. I also used the yellow line there to show you where our vertical asymptote is, and I wrote down in set builder notation this time, again, our domain is x such that x is greater than 0, and our range y such that y is all real numbers, because it goes from negative infinity to positive infinity for y, and our x, it will approach 0, but it will never be less than or equal to 0, but it will go to positive infinity. All right, hope you do well understanding logs. They are a lot of fun once you get the hang of them. Have a good one. Bye-bye.